Okay, hello everyone. In this video, I wanted to uh, quickly go over interpreting our model parameters. And we went over the estimation of our model parameters, but I never went too deep into talking about interpreting. Okay, so quickly before we start, I just want to go ahead and recap, what we're talking about here. So let me go ahead and share screen. Share. Okay. Uh, we're talking about estimating a linear relationship between two variables, x and y, right? And the idea is that we want to uh, come up with this equation, right? And this equation has two parts, right? This equation is actually known as a model. This is a model of our y, right, as explained by x. Uh, the model is a linear equation. Okay. The components are like this. Y is the dependent variable. X is the independent variable. So the data will have X and Y. We're gonna observe X and Y in the data. And then what we do is we estimate the parameters known as beta 0 here, the intercept, and beta 1, the slope. Okay? Now, how do we interpret that slope? In this equation, this would mean that as X increases by 1 unit, Y is going to increase by 9.72 units on average, right? So on average, as X increases 1 unit, the average value of Y is going to increase by 9.72. And that's how we interpret that. Okay, so far so good. So we did the OLS estimation, found goodness of fit in that. And then I showed you the example in class of estimating using stata. The intercept beta 0 is given as a constant term. The slope coefficient beta 1 is given, uh, yeah, as here on the coefficient. The slope coefficient is given here, basically. Yeah, coefficient. So beta 0, 25, beta 1, 0.20. And what I asked you to do to get into the habit of is to write the equation. Get used to writing that equation so that you know exactly what's happening. It doesn't change the size, huh? Okay. So here's the equation. T guess, right, is equal to 25.022 plus 0.201 times mood. And we would interpret this as mood increases 1 unit, T guess is going to increase, and because there's a plus sign here, T guess is going to increase on average by 0.201 units. Okay, that's how you interpret the coefficients. And this is always going to work. Even when we get into time series, the coefficient interpretation is going to be the same, right? So to extend a little bit, okay, in this case, we have only one explanatory variable. So we're going to say that, yeah, as mood increases 1 unit, uh, T gas increases by 0.201. Now, in most cases that we work with data, okay, let me type this out here. Beta 0 and beta 1. I'll type it out later. In most cases, we're not going to have just one explanatory variable. We're going to have many explanatory variables. So we're going to have to extend the interpretation a little bit, right? In other words, in the simple regression that we've been talking about up to this point, it's one variable x. Let me make this clear here. Right? Simple regression has one explanatory variable, while its counterpart, multiple regression, more than one explanatory variable. Okay, so simple regression would be something like, let me find an example here really quick. Um, 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 Multiple regression. Okay, so simple regression looks like this. We have only one x variable, right? Uh, Let me stop here. In a general context. Okay, so in the simple regression, you have only one explanatory variable. Okay, intercept, slope. Uh, but on the multiple regression, you have more than one variable. I guess, in this case that I'm showing here, we have k variables, right? And the interpretation of these are going to be slightly different here, right? Interpretation is going to be a little bit different here. For the simple regression, the change in y for one unit change in x. Okay, so far so good. I talked about that. But for multiple regression, it's going to be the change in each x. For example, if you're talking about beta 1, it's going to be the effect of the change in x1 on y, right? While all the other variables are constant. All the other variables in the model are constant. Right? So in the first case, no other things are held constant. We're just looking at average, what we observe in the raw data. Right? In multiple regression, when we have other explanatory variables, the interpretation is that as x goes up one unit, y is going to change by beta 1, while all the other variables in the equation are held constant. Okay? So that's really important. I'm going to actually update the notes and give it to you guys, but I just wanted to give you this really quick before we move on to other topics. Okay. So that'll be all. And yeah, that's enough for the notes. I'll talk to you later.